students, welcome to our student support program for grade 11 additional mathematics. Today you are going to learn how to apply differentiation and integration to kinematics problems that involve displacement, velocity and acceleration of a particle moving in a straight line with variable or constant acceleration. So let's begin. In a previous video, you have learned that when a particle moves in a straight line where displacement is given, then velocity will be differentiation of displacement with respect to t, and acceleration will be differentiation of velocity with respect to t. Now, we are going to learn if acceleration is given, then to obtain velocity, we have to integrate acceleration with respect to t to get v, and we have to integrate velocity with respect to t to get displacement. Let's apply these concepts to some examples. Example 1. The acceleration a meter per second square of a particle moving in a straight line is given by a is equal to 4t minus 17, where t is the time in seconds from the start. If the initial velocity is 8 meters per second, find part A, the velocity at time t, part B, the times when the particle is at instantaneous rest. Part A, the velocity at time t. V is equal to integration of A with respect to t. V is equal to integration of 4t minus 17 with respect to t. V is equal to 4t squared over 2 minus 17t plus c. It is given that V is equal to 8 when t is equal to 0. Substituting these values, we get 8 is equal to 2 times 0 to the power of 2 minus 17 times 0 plus c. Evaluating this, we get c is equal to 8. Therefore, V is equal to 2t squared minus 17t plus 8. Part B. The times when the particle is at instantaneous rest. At rest, V is equal to 0. 2t squared minus 17t plus 8 is equal to 0. Factorizing this equation, we get 2t minus 1 into t minus 8 is equal to 0. Equating each bracket to 0 and then solving, we get t is equal to half or t is equal to 8. Example 2. A particle moves in a straight line so that at time t second, after passing a fixed point O, its velocity is v meter per second, where v is equal to 8t plus 5 cos 2t. Find part 1, the velocity of the particle at the instant it passes O. Part 2, the acceleration of the particle when t is equal to 6. Part 3, the greatest value of the acceleration. And part 4, the distance traveled in the 5th second. First part, the velocity of the particle at the instant it passes O. V is equal to 8t plus 5 cos 2t. At O, t is equal to 0. V is equal to 8 multiplied by 0 plus 5 cos 2 multiplied by 0. Now, to note that whenever you are using trigonometry in integration or differentiation, your calculator should be in mode radian. Evaluating this, we get V is equal to 5 meters per second. Part 2. The acceleration of the particle when t is equal to 6. V is equal to 8t plus 5 cos 2t. Differentiating, we get A is equal to differentiation of 8t plus 5 cos 2t with respect to t. A is equal to 8 minus 5 multiplied by sine 2t multiplied by 2, to note that 2 is the differentiation of the angle, which is equal to A equal to 8 minus 10 sine 2t. Substituting t is equal to 6 in this equation, we get A is equal to 8 minus 10 multiplied by sine of 2 multiplied by 6, which is equal to A equal to 13.4 meter per second square. Part 3. The greatest value of the acceleration. A is equal to 8 minus 10 sine 2t. The least value of sine 2t is equal to minus 1. With this least value of sine 2t, we are going to obtain the greatest value of the acceleration. A is equal to 8 minus 10 multiplied by minus 1. A is equal to 18 meter per second square. Part 4. The distance traveled in the fifth second. V is equal to 8t plus 5 cos 2t. To calculate the distance traveled in the fifth second, S is equal to integral of 8t plus 5 cos 2t with respect to dt from 4 to 5. S is equal to 8t squared over 2 plus 5 over 2 sine 2t from 4 to 5. Substituting the limits, we get S is equal to 8 multiplied by 5 to the power of 2 divided by 2 plus 5 over 2 sine 2 multiplied by 5 minus 8 multiplied by 4 to the power of 2 over 2 plus 5 over 2 sine 2 multiplied by 4, which is equal to, S is equal to 98.6399 minus 66.47339, which is equal to, S is equal to 32.2 meters, round off to 3 significant figures. Now that we have done a few examples for you, here are some exercises for you to practice. So students, today you have learned how to apply differentiation and integration to kinematics problems that involve displacement, velocity, and acceleration of a particle moving in a straight line with variable or constant acceleration. I hope you have enjoyed it. See you next time.